Hi, welcome back to the Cuzzy Sound channel and the fourth video in the series all about Project 920 Modular Analog Synth. In this particular video we'll be taking a look at the envelope generator, the voltage control filter and the mixer module. So we move in a little bit closer and we can see what these modules are. As you can see, I've got a patch set up so I can actually demonstrate the sounds, but we'll have a look at what the boards look like, have a look at what the circuits are that I've used, and then we'll hear what an envelope, a VCF and a mixer can do to the sound of a analog synth. We start with the envelope and filter module. It's a little crowded with the patch cables, but there's a broad overview. We've got an attack release envelope generator. The switch in the middle there turns a looping function on and off, so it will self-trigger. Then below it we have the VCF, the voltage control filter, which has got cutoff and resonance, and then you've got input for CV and then audio in and out. And the switch in the middle of the panel actually joins the envelope directly to the CV of the filter, so the envelope becomes dedicated to the filter. Now the envelope itself is a design I got from the Analogue Lab Swiss Instagram account. I'll give you a link in the description for that. And the filter, it's exactly the same filter as our little boxes filter. So it's a very simple design. What we'll do, let's have a look at the panel a little bit more close up without all the leads sticking out of it. So the front of the panel actually looks like this. So because I wanted to be able to dedicate the envelope generator to the filter, it was sensible to put them in the same panel. I did something similar on Project 12. I've got a version of this in there. But what I did for this one is I actually redrew or redesigned the strip board layout. So the back of the panel looks like this. So both the envelope and the filter are now on the same piece of strip board. And if you want the actual layout I used, that looks like this. The main difference that you will see on the layout there for the filter section is that on the little boxes filter I used LEDs. So if we have a look at the little boxes filter there, you can see there's the two LEDs. Well, if we go back to the layout for this Project 920 panel, those have been replaced with signal diodes, the 1N4148 signal diodes. Now the thing is that the envelope works great. I'm really pleased with that. And the filter, well, if you're looking for a really smooth filter with smooth transitions that give you kind of either a Moog style feel or an MS-20 style feel, then you're going to have to build something that is a little more sophisticated than this. The whole point about this one is it's a very, very simple design. That means that it has some little quirks, but as I've said in other videos before, I quite like to explore and exploit those little quirks. It gives me something that the commercial gear doesn't have. Okay, right, well, let's have a look at what we've got on the patch. I'm using the square wave oscillator, and the output from that is going into the Vactrol VCA. The Vactrol VCA is being triggered by the output from the envelope. The envelope itself is being triggered from the Baby 8 sequencer on the end there. The Baby 8 sequencer is also providing a CV input to the square wave oscillator. The output from the Vactrol is going into the filter, and then the output from the filter is going into the mixer. So if I set the sequencer going, not exactly disco, but it'll do the job for the demonstration what we do here. So if we turn the attack and decay right down, you can fairly punchy. Turning the attack up, so we're getting more of a slope on the attack. And then turn the release up. So, very simple kind of design there, but by changing the attack and the release, you can change the shape of the sound if you like. Talking about changing shape of sound, if we now go onto the filter, I've actually got the cutoff frequency turned quite low, and it's quite a low bass output from the oscillator anyway. But now manually sweep the cutoff. You can hear what effects the filter has. And then with the resonance, turning it down a bit. If we turn the resonance back up, we're teetering on a bit of self-oscillation coming in there. And if I bring the cutoff right up, it's getting self-oscillation. So that's a very basic demonstration of the envelope and the filter being used as kind of relatively independent modules. So what I'll do now, I'll set up a slightly different patch and I'll demonstrate the looping function on the envelope when it's with it directly connected to the VCF, and we can hear what that sounds like. I made a slight modification to the patch now, so the CV from the sequencer is still going to the square wave oscillator, but now the gate out of the sequencer isn't going to trigger the envelope, it's actually triggering the Vactrol directly, and then the output from the Vactrol is going into the filter, and then the output from the filter is going to the mixer. So if we just start the sequence running as stands, everything's under manual control. switch the filter, switch the link switch in on the filter, so the envelope generator is now linked to the filter internally, and then I switch the looping function on. So I've got minimum setting on attack and minimum setting on release. I turn the attack up. Now, because the period for the looping is set by the envelope's controls, it's not synced to the steps on the sequencer, so you can get some slightly odd things happening. But what you can get, if we turn up the attack and then start turn up the release, so the loop period is extending now, so you're getting an envelope sweep. So you get this kind of a sweep on the filter that's independent of what the sequencer's doing. And there you go, that's the end of the envelope. I've switched the loop function out, so it's not actually having that much effect on it now. Okay, so that's a very quick look at the envelope and filter, both as independent modules and as a linked module. There's lots of other ways you can configure these things and you get all sorts of different effects out of them, but yeah, I think you get the general idea. So we'll move on now and we'll have a look at how I put the mixer together. I've got quite a few more patch cables plugged into the synth now, but that's because we're looking at the mixer module. So I wanted to have, it's a 3-input mixer, so I wanted to have 3 inputs to play with. So I've set up a patch which basically I've taken the output from the square wave VCO, the output from the saw wave VCO, the output from the sub-octave generator, and each of those have got a channel on the mixer. In order to actually get things going as well, I've got the sequence we've been playing with on the Baby 8, but this cable hanging out here, that is the gate signal from the beat step controller, which you can't see, it's behind the synth here. So the clock on the beat step is now driving the clock. Well, it's not driving, it's replacing the clock that's in Baby 8. And then but that also generates gates that I can use. So I've got 2 gate outputs from the Baby 8, so I can drive the Vactrol and the low pass gate. And I've got a CV from Baby 8 is still driving my square wave oscillator, but this is CV from the beat step, which is now driving the saw oscillator, which in turn is internally linked to the sub-octave generator. So quite a complicated patch, but before we get into hearing what all that lot sounds like, let's take a closer look at the mixer panel. So essentially you've got 3 mono inputs and 1 mono output, and you've got a level control on each of the inputs, and then we have an overall master volume control, if you like, on the output. Now I think I mentioned in an earlier video that I'd tried a few designs for this, and this was the one that seemed to work best for what I wanted to do. So the inputs are actually passive mixing. The circuit diagram looks like this. So the inputs are literally just a potentiometer and a resistor, and then they all come together, and then in order to get a signal that is strong enough to drive a line out into something like either an amplifier, or in the case that I'm playing around with here, it's going into a small desktop mixer, just an audio mixer. I've put in an LM386 amplifier chip, which with very few components, as you can see, gives me an amplifier that's I think in this configuration it's about a 20 dB, sorry, a times 20 gain, and it puts out about 1/4 of a watt. I actually found that it will drive a speaker directly, so you could plug a speaker in it and that will drive it directly. But you do have to be careful. You're going to plug headphones in, you have to turn it right down, or use some kind of attenuation. So that's what the circuit diagram looks like. The layout on the back of the panel looks like this. So you can see very simple design. It's just basically sockets wired to pots, which then come together and go into an input on the amp, and the master volume control is on the amp input actually. So there you go. Right, that's how I put the mixer together for this. So what I'm going to do, I'm going to hit go on the beat step, which will start the clock running on here and give me, which in turn will give me the CV inputs on the 2 oscillators. At the moment I've got some volume turned up on the master volume, and looking at this we should just hear what's coming out of the square wave triggered by the Baby 8. So if I hit go, so I can control individual volume of the individual pots. So if I now bring in the saw wave, and you can see with the relative position of these 2 pots, the saw wave is a slightly weaker signal, so it's got more to turn up more than the square wave. And then I have, looking at those switches, 1 sub-octave dialed in. Now that particular music is not going to win me any Emmy Awards or Grammy Awards or anything like that, but it's just to demonstrate the 3 channels. And then, like I said, I've got the overall volume, so I can back that off, turn it up, and all 3 come in together. Of course I've got the individual controls. basically what I've done now is I've provided a method by which we can take up to 3 outputs from the synth and mix them together in a way that they balance out nicely and then have overall volume control. So there we go. Yeah, that's the envelope, the VCF, and the mixer. I'll give you links to other videos that show you more detail on how to put these things together. Plus there's been bits I've put in this video which will show you how some of the stuff has been put together. And well, if I can do this, then I'm not really an electronics expert as such. So yeah, you've got all you need. Go on, have a go, build your own.